Okay, so in this case, we've got O2, which reacts with C₂H₆ to produce CO2 and H2O. And the question is asking us to calculate the volume of the CO2 produced from the reaction. And we've been told that the conditions is room temperature and pressure. Right, so how are we going to go about working this out? Well, we've been given the mass of O2 in the question. So this is kind of the data, the primary data. Like, we've been given that data, and we've also been told, the conditions, right? The room temperature and pressure. But for actually working out the volume for the carbon dioxide produced, we do need a value for the number of moles of carbon dioxide produced, which is not given in the question. We need to use the data available to work that out. And because it's at room temperature and pressure, as we are actually told in the question, 1 mole of a given gas under those conditions would occupy 24 decimeters cubed, right? But let's try to achieve the goal first of all of working out the moles of CO2, right? And how we can do that is effectively leveraging the data we've been given. We've been told that the C₂H₆ is in excess. What can we infer from that? Well, what we can infer from that is that in this particular reaction, all of the oxygen present reacts to produce the products, right? And what that means is we can use the value of the mass of oxygen, work it through the balanced equation. We can effectively work out the specific number of moles of CO2 produced. Okay, so but what we need to do is first convert the oxygen into a number of moles, right? So we're going to use the equation mass is equal to moles multiplied by molar mass. So we rearrange this by dividing both sides by the molar mass to get that the number of moles is equal to mass divided by molar mass, right? Now, do we have the value for the molar mass of oxygen at the moment? Well, no. But what we can do is, as you can see, we've got I kind of put an X up here, but for oxygen, the molar mass would be, we need the relative atomic mass of oxygen to work that out, so which is 16. And as you can see, we've got what we're dealing with is molecular oxygen, O2. So if we actually get, say, for the molar mass for oxygen, O2, well, that's going to be 16 effectively, right? The relative atomic mass 16 multiplied by the frequency of occurrence, which is 2, right? So that's going to give us, of course, it's going to give us 32, right? And that's going to be in grams per mole, right? Now, we can now use that effectively, use that molar mass value to work out the number of moles, right? Using the mass value also that we've got in the question. So the number of moles for O2 is going to be equal to 15.45, which is the mass that we've been given here, divided by the molar mass, which, as we worked out, is 32, right? So divided by 32, right? And that's going to be, so if you do have a go at working that out, what you should find is 0.482812.125, okay? And that's going to be in moles, right? Now, what can we do with this? Well, we're going to need to use our balance equation, right? What does the balance equation tell us? Well, let's set up two equations. Well, let's set up a ratio comparison. So let's set up a ratio comparison. The number of moles of O2 compared to the number of moles of our target, which is the carbon dioxide, right? CO2. So as you can see in the question, it's 7 moles of O2 on one side, so we'll put 7 here, and that then produces 4 moles of CO2, right? So that's going to be 7 in the ratio of 4. So how do we figure out from this what the moles of carbon dioxide is going to be? Well, what we need to do is we need to get a 1 on the left hand side mainly, right? And the way you'd get a 1 on the left hand side is to divide it by 7, right? So 7 over 7, of course, is going to give you 1, right? But here's the thing. What you do on the left hand side, you need to also do on the right hand side to make sure that the ratio actually stays consistent with what we see in the balanced equation. So, which means we have to divide 4 by 7 as well, okay? Therefore, it's effectively a ratio of 1 to 4 over 7, okay? What does this tell us? It tells us that in order to figure out the number of moles of carbon dioxide, we need to multiply the number of moles of oxygen by 4 over 7. So this is effectively to say the number of moles of CO2 is equal to 4 over 7 multiplied by the number of moles of oxygen, okay? So if we do that, because we do have the value for the number of moles of oxygen that's here, it's effectively going to be equal to 4 over 7 multiplied by, just get that in view slightly, 0.4828125, right? So this would give us the number of moles for the CO2. If you work that out, because you're dividing by 7 in this case, and this is not so easily divisible by 7, you're going to get quite a long number. So, I mean, what I'm going to do is I'm just going to give mine to approximately 7 decimal places, right? So you're going to get 0.275892, and then this 8, well, it would have been an 85, but I'm going to basically round this up, so it's going to be a 9, and that's going to be in moles, okay? So moles. So this is actually our number of moles of carbon dioxide, right? And if we refer back to what we were told in the question, the condition is room temperature and pressure, which tells us that therefore, based on the note, and I guess just general knowledge is within chemistry, is that 1 mole or that any given 1 mole will occupy 24 decimeters cubed. So if we multiply our value of moles by 24, it's going to tell us how much the volume is occupied by this specific number of moles, right? So therefore the volume of CO2 in this case, right, is going to be equal to 24 multiplied by this value, so 0.27588929, right? And so if you do work that out, which I would invite you to have a go at that, what you should get is 6.6214 296, right? And that's going to be in decimeters cubed, right? Okay, so if you refer now back to our question, as it makes quite clear, please give your answer to a maximum of 2 decimal places, right? So if you go back, so therefore this would be just simply 6.62, right? That's going to be in decimeters cubed. And we can say that that is to 2 decimal places. So yeah, in this case, this would be basically our answer, right, for the volume of CO2 produced. All right.